So I mentioned that our last unit was focused on quadratics, and that this unit we would be focusing on cubic functions. So these are two different kinds of polynomials, and what this is going to require is that you have knowledge of your perfect squares and your perfect cubes. This matters for factoring and it matters for graphing. So we're going to fill in this table with our perfect squares first. Go ahead and do that. Pause the video for a second and see if you can get all the perfect squares on your own. So hopefully you got all these perfect squares. We've been talking about them for quite a while. And now I'd like you to go ahead and fill in your perfect cubes. I told you guys that you would have to memorize up through 7, so you need to memorize those, but I'm also going to put in 8, 9, and 10 in here just for fun. So there's a list of your perfect cubes. Make sure that you've got this table all filled in and that you memorize up through 7, but that you are also familiar with 1,000 being 10 cubed, because I think that's an easy one that you can come up with on your own. So before we start talking about cubic functions, I'd like to review what we already know about the quadratic function, and I'd like to talk about the most basic version of that, which is y equals x squared. So I'd like you to take a moment and fill in this table based on what you would get as your output, that's your y value, when you plug in the x values for x in x squared. Hopefully all of this rings a bell to you, and you remember that your vertex on this is at the origin at 0, 0, and then that you have other points on either side of it where you go over 1 from the vertex, you go up 1, that's here at these points, over 1 from the vertex and up 1, and if you go over 2 from the vertex, you should go up 4. This is in either direction. So there's these points where you go over 2 from the vertex and you go up 4. So there is our basic quadratic function, and I just would like us to remember this pattern. I know some of us have kind of mastered it and some of us haven't quite yet, but I would like you to just continue to get yourself more familiar with it. As long as a equals 1, we will have this standard pattern. From the vertex, if we move over 1, we also move up 1. If we move over 2 from the vertex, we move up 4, and we can see that in the graph of our function. So now I'd like you to think back to transformations of this parent function, y equals x squared, and what these different transformations do to this. If you'd like to use your calculator because you don't remember how these are changed, that's fine, but hopefully you do remember what happens when we add different things into this equation. Okay, so this function, x squared minus 2, is shifted down 2. Hopefully you remember that this k at the end shifts it down 2, and that would make the vertex be at 0, negative 2. This function here, x minus 2 squared, remember if something is in the parentheses with the x, we have to be thinking backwards about it. So x minus 2 is actually shifted to the right in the positive direction 2, which would make the vertex 2, 0. This function, y equals 2x squared, is not shifted at all, but rather is stretched vertically times 2. So instead of having these patterns of moving up 1 and up 4, we could consider if we moved over 1 from the vertex, we would move up 1 times 2, which would be 2. And if we moved over 2, instead of moving up 4, we multiply that by 2, and we would instead move up 8. So that vertically stretches it times 2, just to get you more acquainted with that pattern. Okay, and then this last one, x plus 2 squared. Remember, we have to think backwards when it's in with x in the parentheses. So this is moved left 2, which would make the vertex negative 2, 0. Okay, so now I'd like to think about y equals x cubed and fill in this table. So think about plugging in these x values for the x value here. Negative 2 cubed is negative 2 times negative 2 times negative 2. So remember, cubing a negative actually keeps it negative. Negative 1 times negative 1 times negative 1. Cubing a negative will give us a negative. 0 cubed is 0 times 0 times 0, which is 0. 1 cubed is 1 times 1 times 1, which is 1, and 2 cubed is positive 8. Okay, and we can also plot these here. So negative 2 is at negative 8. So there's that point. Okay, negative 1 is here. Here's 0, 0 at the origin. Here's 1, 1. And 2, 8 is up here. Okay, so here is the standard shape of a cubic function. Okay, so this is always what a cubic function is going to look like. It may be a little bit curvier, but in general, it will have this sort of S shape to it. Okay, so now I'd like you to make some predictions about transformations. Transformations, remember, are translations, like moving up, down, right, or left, and also include vertically stretching or shrinking. So based on what you already know about y equals x squared, our quadratic function, what we've already talked about last unit, I'd like you to think about what happened when we made these sorts of changes to y equals x squared, and think about how you think that might affect y equals x cubed. I'll give you a hint. They'll probably be the same changes. Okay, so the way this affected the quadratic, it moved it down 2. That's my prediction also for this cubic function. X minus 2 in the parentheses, remember we have to think backwards, that would move it right 2. 2x cubed, just like 2x squared, I'm thinking that that will stretch it times 2. What would that look like? So compared to this, if this were the parent, if it were vertically stretched, it's just going to be steeper. It almost looks like a line, but it still has a bit of a curve to it. So it will be a little bit steeper. And then x plus 2 cubed, just like x plus 2 squared, I think that's going to move it left 2. Before we go on to the next page, I'd like to fill in this pattern over here. So from the vertex, if we move right 1 from the vertex, and this is a little wacky, but this is what we're going to call the vertex. Here at the origin, that's going to be our vertex. We're going to call that the vertex, just like how the vertex is at the origin on a quadratic function. So if we move to the right 1, we're going to move up 1. You notice that that's what happens from the vertex. If we move left 1, we move down 1. If we move right 2, we move up 8. And if we move left 2, we move down 8.